Lesson 4.1, quadratic functions. So the standard form for a quadratic function is y equals ax squared plus bx plus c. And the graph of this function is a parabola, a U-shaped graph. The parent function is f of x equals x squared, and the vertex is the highest or lowest point. So I graphed the parent function, and you can see here that the lowest point is 0, 0, and that it's creates a mirror image. So we have negative 2, 4, and positive 2, 4. So from the y-axis, we went over 2 to the right and 2 to the left. Recall that quadratics have an exponent of 2. So in this lesson, we'll graph quadratics and identify key, let's say, jobs that each part of the equation has in regards to the look of the graph. Recall in Algebra 1 that you used negative b over 2a to identify the vertex, the highest, or in this case, the lowest point, and we used x equals negative b over 2a to identify the axis of symmetry. So we're going to begin with identifying our coefficients a, b, c, and inputting them into the negative b over 2a to determine the axis of symmetry. So I subbed in our b value, the a value simplifies to negative 1/2. So x equals negative half is the axis of symmetry. It's the vertical line. Then to determine the vertex, we just substitute negative half back into the original equation and we'll find out the y. Remember, at any time you should pause and rewind if you get stuck. But anyway, we have negative half times negative half, so that's going to give me 1/4. And here we have 2 over 1 times negative 1/2, and that's going to give me negative 2 over 2, or negative 1. And then we continue to simplify. So we have 1/2 minus 1, so negative half minus 4, y equals negative 4.5, and that's my y value of my vertex. Okay, so we're going to look at the graph. You'll note that it opens up, and that is because our a value is positive. If we take a look at our c, negative 4, it actually falls on the y-axis. So that gives us a point 0, negative 4. Then we can determine its reflection, which is the negative 1, negative 4. All that's left to do is to choose one other x value, sub it in, determine the y, and then figure out its reflection. So I chose negative 2, 0 and determined the 1, 0. So the negative 2 is 1.5 spaces from the x-axis, or excuse me, the axis of symmetry, and the 1 is also 1.5 spaces from the axis of symmetry. 2 final points. The y value in the vertex is at its minimum because it's opening up, but if it were to open down, then this would be at its maximum. One last item to note before we actually try one. The smaller the absolute a value, the wider it'll be. So for instance, if I had x squared, then I know that that graph is going to be wider than if I had 2x squared. This one would be skinnier. Again, this one is wider, and this one is skinnier, or I don't know, thinner. And now we'll try one. Before we begin, notice that sometimes it will be written f of x versus y equals. So f of x is an output where y equals shows a relationship between the variables, but they'll yield the same result. So you may see it f of x in this lesson or y equals. All right, so now we're going to begin. So first of all, we're going to look at our function or our equation and determine if it opens up or down. It opens up because our leading coefficient, when it's in standard form, is positive. Had it been negative, it would open down. Then we're going to determine the axis of symmetry, and I included our little formula here, and we know that the leading coefficient is A, then B, then C. We substitute those values in to determine the axis of symmetry. So pause the video and do that now. We end up with 6 over 2, so x equals 3. So on your graph, now we're going to draw a dotted vertical line through 3. Since we said x equals 3, we're going to substitute our 3 into the function to determine the vertex because we need the y value. So do that now. Pause the video. So when we substituted in the 3, we get f of 3 equals -1, remembering that we could say y equals -1. So the ordered pair is 3 and our -1. So that gives us the vertex. So we're going to plot that point. We know the c value gives us the y-intercept. So our c value is 8. So the ordered pair is 0, 8. So we're going to plot that point. And then using your axis of symmetry, you're going to determine the second point. So you can see we have 0, 8, 1, 2, 3 places from the axis of symmetry, and then we go 1, 2, 3, and that gives us the ordered pair 6, 8. So now you're just going to choose another x value and then determine its reflection and then complete the graph. So pause the video and do that, and then we'll see if our graphs match. I chose to sub in 2, so I ended up with f of 2 equals 0 or y equals 0. So I have the ordered pair 2, 0. It's one space from the axis of symmetry, so I go 1 over, which gives me 4, 0, and then I connected my points. And we know our minimum value is going to be -1. It's the lowest point on this graph.